So good morning, everyone. I'm really pleased to be back here in the UK again at another PyData London event. I think this is my third, so that's really exciting. So I'm also happy to be here today to talk about Bokeh. So as Emlyn mentioned, I've been working on Bokeh for a long time, and it's certainly something that's near and dear to my heart, so I love talking about it and sharing it with people. So quick show of hands, actually, I guess, who has already seen Bokeh or used Bokeh at all? Okay, maybe about half. Okay, good. So definitely wanted to make sure to cover some new stuff in this tutorial that hasn't maybe been presented before, but I'm going to go ahead and sort of go through just the very beginning of the tutorial fairly quickly as well. We'll go at a pretty good clip. So if you want to participate, if you want to actually try things out, basically all of the tutorials are in notebooks. And so you can either go to this NB Viewer link right here, and the static rendered notebooks are there. You can download them and run them locally on your laptop. Or if you want to prefer, you can just clone the GitHub repository for the notebooks, and there's a tutorial directory in there. So maybe we'll give everyone just a couple of minutes to get set up. And if anyone has any questions, I can certainly come out and take a look. Hopefully everyone has, Anaconda would be the easiest way to get started if you have Anaconda installed. I think that's the recommendation they made for everyone. You should be set up with Bokeh. Let's take a look. The version you're going to want is version 0.11. Hopefully everyone can see that. I'm going to do conda list Bokeh here, and sure enough, I have 0.11.1, sorry, is the latest release. I should mention, as everyone's getting set up, that we are going to have a 0.12 release, I believe, next month. And haven't really stated this before publicly, but the intention is that the 0.12 release is actually the last pre-1.0 release. So we should be having a 1.0 coming out pretty soon later this year. So very excited about that, and I'll talk a bit about some of that at the end maybe. Definitely want to try to leave some time for questions at the end. Okay, so like I said, we'll give everyone just a couple of minutes. Once you have either the notebooks downloaded from this link or the GitHub repository cloned, we'll go ahead and get started. And if anyone's having any problems, just raise your hand. I'll come take a look. Maybe let's take a look at what those look like. So if you go to the NB Viewer site, just the top NB Viewer site, you'll see there's a nice link to the Bokeh sort of index page for NB Viewer. And then down here there's tutorial, and it just says to start with the tutorial introduction. So just as a reminder, on NB Viewer, these are all static sort of renderings of notebooks. They are notebooks you can actually run. So you'll want to download. There is a download link here. And that'll work pretty well. There's a couple of exercises here that rely on some separate Python modules that are in that GitHub repository. So that's maybe the best way to get things, but this will be good for 95% of everything if you just want to download the notebooks from here. And so just to give a quick overview as everyone gets set up, we're going to go through as many of these sections as we can. Again, I'm going to probably go at a pretty fast clip through some of the first sections. So we'll start off talking about some of the high-level charts, also the Bokeh.plotting, sort of basic plotting interface. We'll talk about how you can do all kinds of styling, visual attributes. So there's all kinds of things you can sort of configure and style. We'll spend some time talking about layouts and widgets and interactors and how you can add those to even standalone documents. We'll talk about some ways that you can share and embed Bokeh plots. We'll also talk a little bit about the Bokeh model system, which is sort of the foundation of everything. It's really what ties the client library Bokeh.js together with the Python library. There's some new annotations that are available in Bokeh, so we'll talk about that. We'll also talk about some ones that are coming up in the next release. And then really want to make sure to get to today is Bokeh applications. So for folks that might remember or that have used Bokeh for a while, we had a sort of a Bokeh server concept for a while, and we learned some things from the original iteration of that, and ultimately we found that it sort of wasn't satisfactory, and so we basically re-architected it with a lot of help from some fantastic people, including Havoc Pennington, you may know from sort of the GNOME and GTK world. He came and helped us out with that, and the new server is really amazing and fantastic, and I think the proof is in the pudding, so to speak, is because we've seen a lot of people using it to do really interesting sort of applications. And so we'll talk about that quite a bit, and then just a few extra topics in. Actually, I'm also going to talk about the Datashader project, which is a separate sort of project under the Bokeh organization for dealing with larger data sets. I'll give you sort of a quick demo of that. We don't really have time to go into detail today. Okay, so I was going to go ahead and get started talking about the first notebook. Any questions or comments or problems before we just dive in? All right, well, let's hope everyone's here for a nice, lovely morning. It's a little bit early. Not too early yet. It's pretty late for me. Okay, so actually, first I'm going to open up this intro notebook just to sort of show, show things off. So what is Bokeh? If you aren't familiar with it, it's a library for visualization. It's targeted at modern browsers for presentation. You want to be able to have versatile sort of graphics that can really be attached to sort of data in a very natural way. We want to be able to, let me make this bigger. See if that's better. We want to be able to handle streaming data, maybe large data sets. We're really heavily focused on R bindings. At Continuum is what we sort of worked on, but there's actually bindings now in Scala and R, or sorry, we're focused on Python bindings. But there's also bindings now for R and Scala and some Julia bindings that maybe need a maintainer. But it's really exciting that it's possible to create these language bindings for Bokeh. But the main thing, of course, is that you really don't have to write any JavaScript. We want to let people create these visualizations in the browser without having to dive into JavaScript and D3 and CSS and HTML and lots of other JavaScript libraries of the day. So Bokeh is all about being able to do that at a high level from Python, in the language you're already familiar with, that you're already using to be productive with other tools. Okay, so what can you do with Bokeh? That's sort of what it is. What can you do with it? Well, you can do a lot of things here in the notebook. So you can create fairly complicated charts in the exploratory data analysis sort of way from one line, right? So if we have some data, we want to create some histograms from it. It's just a one-liner. So Bokeh does have this very high-level interface that's available that you can use to create histograms and box plots and horizon charts, and the chord graph was just added by a new contributor, and all kinds of things. So these are intended to be very quick, very easy to get started with. A lot of them are very focused around the data frame, and so this is that Bokeh.charts interface. And so here's just an example of that. We'll dive into some details in a second. Other things you can do with Bokeh is you can create really sort of web-ready interactive visualizations that are very nicely styled and nicely themed, right? So this is a reproduction of this Hans Reising example that shows the fertility rate versus life expectancy over a number of years, and so you can have this nice slider, and you can scrub it, and you can see the data change and respond to me when I scrub that slider. This is not a server app. This is just basically a standalone HTML document. You could email this to someone; it would work fine, and we'll see how to create some things like that in a second. I just realized I've got this open up in Safari, which isn't good. Let me open this up in Chrome. So we do have an issue with WebGL in Safari we're still working through, but if I open this here in Chrome, should be able to see things render pretty well. So we do have some WebGL support. We support sort of circles and lines right now, so if you want to be able to get into sort of a slightly more medium data size sets, you can handle those with Bokeh as well. Let's get this to load. There we go. Taking a while to load. There we go. Well, not sure why that isn't showing up. Okay, well, we'll have to come back to that WebGL. We're still working on, that's a pretty new feature. But lastly, the main thing is, and that's what I'm going to talk about today, is creating these data applications, right, where you can have widgets and interactions, selections that are tied to Python code that can inform further computations. Maybe you want to do some machine learning algorithms or some NumPy or SciPy calculations based on some selections or on some sliders. You can do that with Bokeh. And so here we have an example of that. This is actually running on bokeh.demoplots.org, so I'm here over conference Wi-Fi and I'm able to use this just fine. So this app's been embedded in an iframe here in this notebook. So it works, I think, by having a pretty nice architecture that's very decoupled. So basically we have a set of models in Python, some objects that represent all the things you might want to put in your visualization, widgets or layouts, sliders, axes, grids, glyphs. All of these things have an object that represents them. Those get serialized to JSON. They get moved over to the client, in the browser in this case, and a completely identical object model, object graph is created inside the client. And that's really powerful because, in particular, you can have other languages like R or Scala or Lua or Julia or whatever create that same JSON, and they can all drive Bokeh plots in the browser as well, which is we've seen people do. But it's also really powerful when you connect this with the Bokeh server because these different object graphs can be kept in sync. So if you make a change in the Python side, that's automatically reflected into the browser. If you make a change like a selection or a widget manipulation in the browser, that change can get reflected back to the Python as well. And so this sort of feedback loop is very powerful. Okay. And we'll see some examples of that. So getting set up, you can run this code at the bottom. You should see something fairly similar. I've got sort of IPython 4.2 and looks like Pandas 0.17, although I think the newest version of Pandas just came out maybe a couple of days ago. And again, this tutorial now is sort of geared for Bokeh 0.11.1. So pause just for a second and see, does anyone have any problems getting set up? Is everyone? Yes? Question?
Import error, no module named core templates.
Named what?
Core.templates.
Oh, so you should, yeah, so there was something that changed. Oh, so you have an older version of Bokeh, I think, is my guess. Yeah, I believe that's it. So there was a change that moved things there, and so if that import fails, then I think you have a version of Bokeh that's older than 0.11. So just try that first, and then I'll come by during the next exercise, take a look. Any other questions, comments? Okay. Well, let's go ahead and charge forward. We'll go through the charts. All right. So charts.ipynb. Oh, I don't actually want to do this on NB Viewer. I want to do this on a real live notebook right in front of me. So, like I said, one of the things that's really nice about Bokeh is we have added this Bokeh.charts, a very high-level interface recently. It's sort of the newest interface, the youngest sort of member of the Bokeh API. And so it's undergone some sort of some experimentation and evaluation. I think we finally settled down to sort of a framework that we like. We have new contributors adding new charts now, and so I'm really excited about this for the future. I think it's going to be a lot of expressive capability that's opened up. But let's take a look at a couple of kind of charts that are very common. So first thing is you might want a scatter plot. So we have some data here. So built into data, or built into Bokeh is this data set, the iris data set. And by the way, if you need to download this data set, the way you can do that is this. Let me insert a cell above. So if you import Bokeh, and then Bokeh sample data .download. I don't actually want to run this because I've already got it downloaded, but that's what you would do. Make this font bigger as well. So execute that bokeh.sampledata.download. That will download all the sample data sets that you might need. Okay, but anyways, we've got this iris data set. We're going to take a look at it. So the first thing we do is we execute this. We look at our data frame, and we say, sure enough, it's just got a couple of columns about these species of flowers. I think there's three different species, and they're measurements for the sepal length and the petal width of all these different flowers. And so you can sort of take a look at that in different ways. And so let's take a look at it with a scatter chart. So we import the scatter chart. And then it's just a single line, right? So we tell it, what column do we want to represent the x coordinate? In this case, petal length. What column do we want to represent the y coordinate? In this case, petal width. And sure enough, we get a chart out. Need to execute the lines up here. We get a chart out that has all that data. And so maybe that's what you want. And that's fairly straightforward. We get sort of one line. But we might want to actually do things like sort of color the markers by some other field. And so we can do that very easily. In this case, we can say something like color equals species down here. And now when we get the chart, it's going to actually do that. And now all the different species are colored according to their value. And we also get a nice legend up here automatically as well. So again, that's the whole idea behind this high-level charts interface, is that it's really supposed to be very quick. It's not the interface you might use to build like a highly polished sort of web application with, but it's great in the notebook. It's great for sort of very fast usage. Okay, let's go ahead and take a quick exercise. Give you guys just a couple of minutes to do this. So we want to go ahead and pass a column name as the marker keyword argument in this example here. We can see what happens if we also do that. So just go ahead and start from this line and paste it into the cell here if you're running locally. And so we've got marker equals species. I'm going to go ahead and do marker equals species again. So we're going to both color and specify a marker according to the species column. And sure enough, now you can see that not just the color has varied, but also the marker. So we have circles for setosa and squares for versicolor and triangles for virginica. And so that's a really easy way, again, to sort of get things out. So you don't have to do a lot of effort to get this kind of faceting of your data according to the different dimensions. And we should be increasing this even more. So we're working on some really nice layout capability now. So we'll have the ability to sort of facet and have multi-plots according to these dimensions as well. I'll give everyone just a minute to try that out. If you have any problems having it run, just let me know. So that's scatter. Again, very high level, intended to be just sort of useful for exploratory data analysis, getting started very quickly. Bar charts, another really common sort of chart. Let's take a look at that with this auto MPG data set. So here we have this auto MPG data set. It's a data frame. A lot of the charts are very data frame centric. So here we've got some columns that represent things like miles per gallon. I know miles is a very ridiculous unit. Cylinders, displacement, horsepower, weight, all these things for different cars. And so we want to be able to show maybe some of this data using bar charts. Let's take a look. So the way bar works is that you have a label. And that's going to be what labels the x-axis. It's going to group the data according to this dimension. And then values. And these are the values, another column, and you want to aggregate over these values. And then, of course, you give it the aggregation you want to do. So let's see a concrete example. In this case, we give the label cylinder. The values are miles per gallon, and the aggregation is max. So what that gives us is a chart that is the maximum MPG by cylinder. And sure enough, down at the bottom, we have it labeled by cylinder. Here's the maximum MPG for each group of cylinders. So that's nice as far as it is. But we can go ahead and do other things as well. Like let's say we want to do grouping. You know, we've got sort of a nice simple chart here, but we might want to do grouping. And so there's this origin field in the data, which I gather is maybe a manufacturer. I'm not exactly sure what that is, but there's whatever it is, we might want to group by that origin field. And so we can just pass in a group parameter and say we want to group by origin. And then if we execute this, sure enough, we get a nice grouped bar chart. And so again, because we've done that, automatically we get a nice legend out that explains, you know, what each different color means. And so this one, by the way, is by year. So here we've labeled it by year. So it's miles per gallon, the median, grouped by origin. So this is the median miles per gallon by year, and then it's grouped by origin. So that's a nice example. So we can take this example, and for the next exercise, we can go ahead and modify this as well. So there's also a stacked parameter. And so I'll let everyone here sort of modify that. We'll take a minute or two and let everyone play around with that to modify this example to get a stacked bar chart instead of a grouped one. And so at the end of the day, you should end up with a chart that looks pretty much like that.
The ordering of the ordering in the stack, sort of found a way to do it?
So that's a good question. Right now, I don't know if there is a lot of control that you can do with that, but that would be a great feature, and it probably wouldn't be very hard to add. So we can talk about that in detail. But yeah, so we've actually recently added, some folks came in and asked about being able to order some other things in some different charts, and so we were able to respond to that. And I think actually maybe a new contributor came in and helped out with that. So these kind of, there's a lot of features. So like I said, charts is sort of the newest API. There's a lot of features that we'll want to add to. People just need to point them out. but yeah, so that's a good question. Okay, so again, hopefully everyone has a chance to sort of execute this. So again, actually, first another question: who's familiar with the notebook, or who's not familiar with the IPython notebook? Most everyone here. Okay. If you have any questions, let me know. Notebook's pretty awesome. It's a nice way to sort of get started quickly. Okay, so here I took the line that I had before, the bar chart for the auto MPG data. Again, I've labeled it by year. I want to aggregate over the miles per gallon. I want to get the median for every year, but I also want to sort of stack it by origin. So I want to break the bars up into different sort of subcomponents by origin. So I have that stack equals origin parameter that I passed, and that gives me this nice stack bar chart. And I changed the title as well. Okay. Another pretty common chart to want to use is a histogram, right? So a histogram lets us take a series of data. We want to get sort of a sense or a feel for what the distribution of values is for this data. And so a histogram will let us do that. So we have a built-in histogram in Bokeh.charts that we can use very quickly to get started. So kind of creating a synthetic data set for this case. It's a little bit weird. I'm basically stacking two sets of 1,000 values together. One is 1,000 values picked from a normal distribution. Another is 1,000 values picked from a log normal distribution. This is just for demonstration purposes. But you can take a look at the data. If we look at the data frame, we can see, sure enough, there's the first 1,000 are from this normal distribution. The second 1,000 are from log normal. We've just labeled each value with which distribution it came from. So we can import histogram from Bokeh.charts. And then again, it's very data frame centric. I just say I want a histogram of this data frame. The values is the column that I want to actually do the histogram over. I want 30 bins. Oh, I actually need to evaluate I actually need to run the cells above first. And then when we do that, we get a nice histogram, right? So it's going to take a little bit of time to actually compute, there we go, compute a histogram. And we get the histogram out, and sure enough, so this looks a little bit maybe weird, right? Because this is actually a histogram of all the values, which is comprised of both this normal and this log normal distribution. So you can sort of see that it's kind of strange there, or I mean, it is what it is. But so we might want to actually create multiple histograms. So this is the exercise. There is a parameter in here. Let me go ahead and make this comment here. There is a type parameter here that we can add to histogram. and it will give us multiple histograms. So at this point, I'm actually going to refer everyone to the documentation as well. Do have a lot of documentation up on bokeh.pydata.org, so let me go ahead and point everyone there so that when you're doing exercises, you have some idea of where you can sort of get more information. So if you go to the user's guide, we have quite a lot of information on our user's guide. Let me make that font a little bit bigger. And in this case, we might want to navigate to the high-level charts section. And so if we go there, we can see a lot of sort of actually information, sort of like conceptual information about charts and data frames. We can also see things about, for instance, bar charts and box plots, histograms. We'll be adding more to that later. So this is where you might want to go to sort of get more information about how to style and theme and change lots of different colors, right? So anyway, in this case, you can see that the value that we want to do to get multiple histograms by color is this color field. We give it a column for what we want, and that will, so if we do color equals type. Now we actually get a histogram for each of the groups, right? So basically when we say color equals type, what that means is look in the type column, which again says normal or log normal, and group them according to what the values there are. So there's two groups, one for the normal distribution, one for the log normal distribution, and generate separate histograms for both of those automatically, right? So this allows us to do things very quickly. So again, I'll give everyone just a little bit of time to play around with that. Let's add a legend to it as well. In this case, I just tell it where I want the legend to go. Legend equals top left, and it'll put it up here in the top left. Yep, questions? No. Mm-hmm.
How do you go about checking that?
Oh, that's interesting.
So I think just added stack origin. Is this a browser issue or is Chrome?
No, maybe not. That might be. So you got grouped and stacked. I expect that there's maybe an issue with grouping and stacking together. So try just, because you've grouped and stacked by origin. Okay, interesting. So it's stacked them, but it's also grouped them by origin. So if you maybe give a different, yeah, so that's actually very interesting. I would love for you to make an issue about that. That's something that we could either warn about or, I mean, it's kind of a combination that doesn't make sense to both group and stack by the same field. And so we could probably just detect that and say, hey, this is kind of a weird thing to do. But that actually, it makes sense to me why I did that, but it's also not useful to do that. So, okay, cool. Okay, so last section here. Any other questions before I finish up a quick review of charts? Okay. Last section here is boxplot. So again, we want to go ahead and import our boxplot from bokeh.charts. Boxplot, if you're not familiar, is another way to represent sort of distributions of data, right? And so we'll take a look at one. So here we're going to use that flowers data set again. I want to label by the species, and for every species I want to look at a box and whiskers chart for the petal width. And so we can go ahead and do that. And sure enough, for every species down there on the x-axis, I've got this box and whiskers chart that represents the distribution of data for that particular species, right? So this is the petal width in millimeters, and you can sort of see that all the species have pretty different characteristics, for their petal widths at least. I've given it a color parameter here. I've given it this sort of nice dark red color that I like, but it's also possible to have it color them, by the species itself automatically, right? So if I go ahead and copy this, and just for the sake of time, I'm going to go ahead and just do this exercise. If I say color equals species, and I give it a column name here in the data, just type that. If I give it species, then it'll actually give a different shade of color to each of the box and whiskers charts, and we could add a legend as well if we wanted to. Let's go ahead and do that. Legend equals top left. And so now we actually get a legend that tells us what those different colors, which species they correspond to. So again, there's there's several other charts that we aren't going to cover here just for time. There is a horizon chart. There is, again, this new chord chart that was just added for sort of visualizing different networks. If we go to the user's guide in the docs, and we go up into the reference guide, we can go to bokeh.charts. And we can see a lot of different types of charts here. There's sort of an area chart. And all the reference guide has nice examples in all of these as well. There's an area chart. There is the box plot. There's this sort of circular sort of donut chart. Heat maps as well. There's our horizon chart that I mentioned. There's line charts, scatter, time series step charts as well. So again, all of these are here and have nice documentation. I encourage you to check those out. We're going to go ahead for now and move on from charts, just for the sake of getting to some new material. Okay. So that is, let me close all these old notebooks. That is charts. The next notebook we're going to take a look at is this 0-2 basic plotting interface. So any quick questions before we start this section? Like I said, I'm going to sort of tear through this, this material, sort of review material pretty quickly. Okay, so there's another interface that's a little bit lower level than Bokeh.charts. It's called Bokeh.plotting. And it's, I would characterize it as roughly the level of sort of verbosity of, Matplotlib or MATLAB or something like that. The idea is that you can very easily get sort of a default chart, a default plot. It has axes and grids and things like that sort of make sense for default. And then you can throw glyphs at it, throw shapes at it. Any kind of sort of visual object you want, you can sort of throw that, scatter that across the plot, and you can attach the attributes of those visual objects to the data directly, right? So you might want to have circles, and you want to vary the radius by some field, and the color, or the outline color, or the fill color, or the fill alpha by all different fields, and you have this kind of control to do that. So again, we're in the notebook. We're going to import output notebook so that we can see things there. We're going to import this show function and figure as well, and so that we load Bokeh in the notebook. We can see that it's loaded. What does this Bokeh.plotting interface look like? Well, the main thing we start with is this called a figure. Let me make this a little bit bigger font. So we call figure. In this case, we can also tell it we want a specific plot width and plot height. And then we're going to call circle, and we can pass actual lists or arrays of data to it. A little bit later on, we'll see that we can pass what's called a column data source to it as well. But in this case, we're just going to pass literal lists of data. For the x-coordinate, the y-coordinate, we're giving it a fixed size. We can say things like, I want the line color for the circles to be navy, but I want the fill color to be orange, and I want there to be an alpha on the fill, and we can show this result, and sure enough, we get exactly that, right? We get a bunch of circles that are 15 pixels sort of in big, in size big. The outline color is navy, the fill color is orange, and the fill alpha is 0.5. But the important thing to mention is that, I've given fixed values for things like the color or the size, but any of those values could be given vectors or arrays of data, and then you would get, all the different circles would have different sizes or different colors, and we'll see that in a second. So quick exercise, why doesn't everyone try copying and pasting this code here, and instead of size, change that to radius, and we'll see what happens. Give everyone just a second to do that. Okay, well that's pretty big, right? So let's maybe change that. Okay, so again, I copied and pasted that. I changed the size parameter to be radius, and when I do that, I get just a giant, orange sort of thing here. But if I go ahead and zoom out, if I select my my wheel zoom tool here and I zoom out, we can sort of get an idea of what's happened. So radius is in screen data units, right? So size is always typically in screen space units, in pixels, but radius is usually measured in data units. So this is saying I want a circle that's 15 units wide in data space, and so you can see here that sure enough, these are all about 15. So let's change that to something smaller. In this case, I'll change it to 1.5, and sure enough, you can see now we get circles that are a little bit smaller. But if you can look at the actual radius, sure enough, this one starts here at 3 and it goes down to 1.5. It has that radius that we expected. And it's also important to note that the circles, their size changes as I zoom in and out. Because the radius is in data space, the circles respond, and the data space dimension there is preserved. That's different from the size. Because I've given the size in pixels, if I zoom in and out, these circles don't get any bigger or smaller. They're always going to have that same screen space size. So this is sort of another important distinction to consider. Okay, there's a lot of different markers besides circles. There's square, things like that. Here I'm illustrating that, as I said, if we give an array of values for size, then we'll get a bunch of squares or markers or whatever that have different sizes, right? So here I've given an array of 5 values for the size, and so each of these squares now responds to that and has a corresponding size. So pretty much any visual attribute of these glyphs, of these markers, can be tied to data in that way. There are a whole lot of them. Things like circles with X's and crosses, triangles, all of these. These are just the standard markers. There's some other glyphs we'll talk about in addition to the markers in just a second. Okay, so let's try plotting some different markers. I'll give everyone here just a second to do that. Sort of play around with this. I'm just going to copy and paste the code. Maybe we'll do circle X, and we'll give it things like line color equals fire brick, and fill color equals. I have all these fun CSS colors that I like using. Let's make that even. Fill alpha equals 0.3, right? So here I've added a new marker, circle X, and again, you can see that I can specify things like the line color independently of the fill color. And again, those could also be arrays of data. If you want to have everything colored differently, that's perfectly fine to do. Okay. Line plots, obviously line plots are something you probably want to do. So there's a line glyph, very easy, p.line. Again, you give it an array or a list of x coordinates and y coordinates. You can give it properties, things like line width. And you can see the plot will respond to that. If I say line width equals 4, that's great. Or I can say something like alpha or line alpha equals 0.3, and now it's got an alpha value. So very sort of straightforward to get the sort of appearance you want out of your plots there. Images, another one that's pretty interesting. Not going to go into too much detail about this. You can see some other examples. This one uses NumPy. Most of the examples I've tried to make so that they don't rely on NumPy or anything like that. But this one does a little bit. We actually create an array of RGB values, so red, green, blue values for the image. And so we set a ramped bunch of red values and a ramped bunch of, I think, blue values there. And then we can pass this to the image RGBA glyph, and that will give us an image, right? So that gives us the ability to display images, right? So that's pretty nice as well. Some other kinds of glyphs, again, we're not going to go into a lot of detail about these. Things like rectangles and ovals, obviously, those can be rotated and scaled. Segments and rays, so segments are line segments that have 2 endpoints. That you specify rays, you can give a single endpoint and have it extend off into the distance. Wedges and arcs, annular wedges, those kinds of things are all available. There's some specialized curves, Bezier and quadratic curves occasionally get used. Just recently, someone added an ellipse as well. So ovals are actually drawn using Beziers, and someone added a true ellipse curve in there. We're going to probably be adding a V-bar and H-bar primitive glyphs as well very soon. So we'll give everyone just a minute to play around with this, trying some examples in the user's guide. So if you go to the user's guide again and go up to user's guide and plotting with basic glyphs, you can actually see a lot more examples than are here in the notebook. And so you can pick any of these and sort of play around with things. Again, all of these have nice inline plots as well with the code that generated them. So I'll pick one here. Just pick some rectangles. Those are probably pretty useful. Oh, I told it to output file. So definitely let me know if anyone has questions as you try things out. In this case, I just plotted some rectangles, but you could imagine plotting whatever glyph you want that's useful. Rectangles, again, take x values, y values. You can give them a width and a height. You can specify the color, which is, color, by the way, is just a shorthand for both line color and fill color at the same time. And same thing for alpha. Alpha just is a shorthand for giving the line alpha and the fill alpha together. So I could explicitly say, fill color equals this, and then line color equals the same thing, and that would be equivalent. If I want to give both at one time, I can just say color, and so it's just a little bit of a shorthand convenience. So I'll change that back Okay. Okay. Last thing here is that it's really easy to draw multiple glyphs together. So we've seen drawing one sort of glyph at a time with this interface, but it's very easy to just draw multiple ones. You just add more glyphs, right? So here I've got some data. I want to draw lines and circles on the same plot, so I just call p.line with my x and y data, p.circle, however I want that to look, and then I call it, and sure enough, I've got lines and circles, right? So very easy to make sort of line charts with these markers on them, or whatever you'd like, whatever combinations you want. Maybe for a more complicated example, just right quick to show, I'll go over to the gallery. That's also another thing to point out here. The gallery is really useful. We're hoping to expand this quite a bit in the next coming month or two, but it's already got quite a lot of examples here. You can see this color scatter plot, and here's sort of a really interesting example that shows a lot of different kinds of things together. So this has got obviously a great mini glyphs, rectangles and circles and texts and annular wedges here. And if you scroll up, you can see pretty much all of those glyphs represented, rectangles and wedges and text and lines and that sort of thing. So, okay. All right, so that's the plotting interface. Again, very quick sort of review. I'll close that notebook. Any questions about that before moving on to styling? Okay. So then the next section is just about how do we customize all of these things, right? So how do we make them look differently? There's definitely a lot more information in the user's guide, but let's go through some of the examples that are here in the tutorial and practice a bit as well. So again, we want standard sort of inputs. I'm going to use Bokeh.plotting excuse me, for all of these examples. So I import from that. I run output notebook, and I can see that Bokeh.js is loaded. There's a few notes here that you can read sort of at your leisure about colors and properties. Basically, there's a lot of different ways to specify colors in Bokeh. You can give the CSS color names, RGBA, hex values, tuples, things like that. And then also some words about what we call properties, right? So basically, I mentioned Bokeh has all of these objects that represent everything the plot might have, things like a glyph, a line glyph, or a circle glyph, or an axis, or a grid. And so they have what we call properties, so things like the line, line color, line alpha, line width, those are line properties. Fill color, fill alpha, those are the fill properties. And these are typically just attributes on those objects that you can set to have whatever value you want. And so we'll see a lot of examples of that here in this section. So first thing, let's create a plot. Just see that we can modify some properties of the plot, right? So here I create a plot using figure. I give it a plot width and a plot height. But I can also say things like outline width equals 7, and outline line alpha equals 0.3, and outline line color equals navy. And sure enough, the outline of the plot itself has those attributes, right? I've changed the values and the appearance of that outline by setting those property values. So the exercise here, give everyone just a minute to try things out, is you can copy and paste this code, and you can sort of change things however you might want. You could give something like an outline line dash, p.outline dash dashed, or you can also give it a list of numbers for the dashing. We can maybe change the color, go to my favorite fire brick, maybe even change the alpha to 0.7, maybe make it a little bit thinner. And sure enough, now I get this nice dashed outline, right? So I'll let y'all play around with that a little bit if you'd like to. But again, we're setting the properties on this plot object to change its visual appearance. The things that are actually drawn inside the plot, these circles, again, those are referred to as glyphs. And we can affect their visual properties as well. In fact, we've already done so. In the previous section, when we called something like p.circle and we said line color equals red, fill alpha equals 0.2, we're actually setting the values of these properties when we call that glyph function. But it's possible, if you get a hold of a glyph, to actually set them as attributes on the object. And so the easiest way to do that is when you call something like p.circle, it returns what's called a glyph renderer. And then you can get the glyph off of that and set its fill alpha, its line color, its line dash, its line width, right? So here, let's take a look at what I've actually set. I've said r.glyph size equals 50, and so these are big, nice 50 pixel circles. I've set the fill alpha to 0.2, and sure enough, that's fairly transparent. I've set the line color to fire brick, and the line dashing is equal to this sort of long dash, short space dashing. And I've set line width equals to 2. And so if I get a hold of this glyph, I can set these property attributes on the glyph, and that's another way that I can control the visual appearance. That's especially useful because there are other types of glyphs on this glyph render. There's this r.glyph, but there's also something called the selection glyph and the non-selection glyph. And I can use these to control how things look when they're selected. And so let's take a look first, and then maybe I'll say a few words. So What do I mean by that? Well, Bokeh has a lot of tools that can do things like selections, like a lasso tool or a box selection tool, or this tap tool that I've added, which means if I click on something, that it'll select it. And I can control the visual appearance of what those selections look like. In this case, I've said I want the selection color. When something is selected, I want it to be firebrick. But when it's not selected, when there's a selection active, I want the things that are not selected to look like this. I want the fill color to be gray and the alpha to be 0, 2, and so we can see them sort of grayed out. Let's go ahead and change that. If I change this line alpha to 0.3, and I can change something like the non-selection line dash equals dashed, right? Oop. What do I do here? Line dash. Oh, maybe we can't control the line dash from here. I didn't know that. Okay. So you can control. I guess you can just control the fill and the colors and the alpha of these mostly. But that's the point is you do have control over that. Here I'm hitting the shift key to do a multi-select. But again, all the things that are selected have this this policy that I specified up here, where everything is firebrick, and everything that's not selected gets this policy sort of right here. And if there's no selection active, I hit the escape key, it just gets the default, right? So the default color is just sort of this blue color, and that's, whenever there's no selection active, that's just how all of the glyphs are going to be drawn. One more thing to mention about that is that there's also the notion of a hover. So we have a hover tool that allows it to sort of do inspections, and you can also configure what the appearance of hovered glyphs look like as well. So there's this .hover glyph on the renderer, and so I can change things for it. In the same way with plotting, I can give hover alpha and hover line color. And so if we take a look at that, this example here, what it's done, I've combined it with a hover tool, and now as soon as the glyph is hovered, it changes to that hovered appearance. And so this is again just a way of styling. It's a little bit more sophisticated and advanced, but there's more information in the user guide. But I did want to make a point to at least show that this sort of thing is possible. I guess we could go ahead and let everyone spend a few minutes, although we're running a bit behind where I'd like to be. So actually we'll go ahead and move on. There's an exercise here if you'd like to just create a plot and sort of play around setting these different properties. You could, again, just copy and paste the code up here and sort of play around with that. But I'll let you do that on your own time. Let's go ahead and keep moving because there's quite a bit of material to go through. Other things that we can style very well, things like axes and the grids, right? So our Bokeh.plotting figures come with a default axis and default grids, and they sort of make a lot of sense, but we might want to customize what they look like. And so all of those axes and grids have all these properties, things like the axis label, but also the major label text color, right? That's the color of the font that's used to write the labels under the tick marks. All of these different properties, they have like the major tick. You can change the color of the ticks. You can the minor tick marks. You can change the line properties of those, how far they extend into the plot, how far they extend out of the plot. There's a lot of sort of knobs and dials that you can turn if you really want to customize things. Easiest way to get a hold of the axis to make these configurations is on plots. There is a .axis attribute, and if you can say p.axis, it gives you back a list of all the axes. But it's actually what we call a splatable list. It's nice that you can say p.axis and then set an attribute on it, and it will set the attribute for all of the axes at once, right? So in this case, let's see an actual example. Here I call figure. I pass in some x and y values for the x marker. I give it a size, a line width. But then I say p.y-axis. I want to give the major label orientation to be pi over 4. And I want the major label orientation of the y-axis to be vertical. And sure enough, now the x-axis labels are rotated by pi over 4 radians. And then the y-axis orientation has been set to vertical. This example, the next example here, does quite a few more customizations to the axis, right? So we can take a look at what it actually does. Here I'm using the asterisk marker, so I'm getting asterisks sort of scattered around my plot. But I want to change the label to temperature and the label to pressure for y-axis. I want to change the line width and the line color to 3 and red for the x-axis, so we have this big bold x-axis. For the y-axis, we change the text color and the label orientation, and sure enough, we have orange labels that are oriented vertically. And then finally, for the x-axis, or for all the axes, we want to maybe change the tick. And so we give a negative value for tick in, which means it doesn't actually extend into the plot. It actually starts outside the plot. and the tick out is even bigger than that. And so now we can see the tick marks actually are outside the axis there. So we have a really very fine control over customization of the way the plot looks. If you need to sort of exert that sort of customization, you absolutely can do that. All right, so I'll let everyone copy and paste this example and sort of play around and change some of these, add some different properties. So we'll just take a minute to do that. Put this here. Do equals. Okay. So I just made a couple of small changes here. I'll talk about them all while you guys work. I just changed some of the minor tick parameters here. Instead of having the ticks sort of be on the outside, I have them now on the inside. So I've changed minor tick in to be 6 pixels in, and then the minor tick out is actually minus 3 pixels out of the plot, so that's actually inside the plot. And I've changed the color to red, and it's probably kind of hard to see, but if you look at it, you can see the little minor ticks are red, and now they're all inside the plot. So again, really completely customizable in terms of what you want to do. So any questions about that first? Yeah.
Can we ask for the tick levels to have only even numbers?
Oh, yeah. So the question is about can we customize the ticks to only have even numbers? Yeah. So we'll get to a little bit more about that maybe later, and I can point you to the documentation. But the way the axes work is they have something that's called a ticker, which is something that determines where the tick should go. And then there is also a tick formatter, which determines what the format of the labels should look like. And so there's some built-in ones that let you specify, I want a date time sort of nice ticking across date scales, or I want to do a single interval ticking, or you can just give it a fixed set of values. So it's very customizable. There's several that are built in, and you can go and see that in the user's guide. But yeah, so by default, there's just sort of this nice ticker that works across scales. So if I zoom in and out, you can it picks what are called, quote unquote, nice numbers, which are basically multiples of 2, 5, or 10. And it just sort of automatically does that. But if you want to have finer control, you can specify a custom ticker. Yeah. Okay, good question. Okay, moving on quickly. I want to go through this really quickly, maybe just to show some things. The grid lines, exactly the same, have these properties. We can use p.xgrid or p.ygrid to get the actual corresponding grids out. In this case, I'm saying the x-grid I don't want to be there at all. So the x-grid is the grid that intersects the x-axis. I don't want it to be there at all, so I just set the line color equal none. But I want the y-grid to have a line alpha and a line dashing. And so now I have this sort of nice alpha dashed y-grid. So if that's more appropriate, that's very easy to accomplish. There's also a grid band. So if you want to have filled bands on your grids, that's certainly possible as well. So you can give the band an alpha and a color, basically filled properties, and you'll get these nice alternating bands on your plot. Running a little behind time, so let me go ahead and skip. Last thing I'll mention is legends. Legends are also customizable. There's a lot of information in the user's guide, so I'll sort of defer to that. But the way legends work with the Bokeh.plotting interface is that you can give basically a legend parameter to these glyph functions, and that will accumulate all of the different glyphs that have the same legend name, and it'll draw a nice legend here for you, right? So here, there were 2 glyph functions that I called 3 times sin x, and so I can see that both of them, the square and the line, are represented faithfully here in the legend, right? So again, a lot more information about legends in the user guide, but we're running a little bit behind time, so let's see. So I think in order to get things on time, I'm going to go through the next section, interactions, because it's pretty neat, and then probably skip maybe onto the server thing just to make sure we get to it, because I promised that we would cover that today. So let's go into the 4th notebook here for interactions. With the layouts, widgets, and interactions, and then we'll go on to the server. So one thing there's a note here is that some of the functions that are in this notebook right now are going to be deprecated in the near future. We are doing a complete overhaul of our layout system. Our fantastic contributor, Sarah Bird, is working on that. It's really exciting. It's going to be a nice, much more responsive. She really cares about making things sort of responsive, and as she calls them, quote unquote, webby. And so we're doing a lot of really heavy work to make the layout system much better. But as part of that, we're going to be deprecating some of these. They'll still work, but they will give you deprecation warnings in the near future. This will all be done, though, before the 1.0 release I mentioned. OK, so in particular, there's a couple of different layouts. Execute the first few cells here. So the first thing to mention is that Bokeh has this notion of layouts, right? So here I've got 3 different plots that I create, S1, S2, and S3 with the figure. And then what I do is I put them in this grid plot, right? And so grid plot is something that simply lays out the plots, in a grid that I specify. So that's really useful. Don't need to worry about that. I do want to demonstrate some of the other layouts as well. If I go down here. So if I instead do vplot, and I put this in a vplot for vertical plot, toolbar location equals none, doesn't apply to that. And also gets children. Helps if I call it the right way. Oh, sorry. Just give it the plots that I want to be vertical. Sorry, little brain freeze for a second. So right, so I created this vplot that I imported, and then I call vplot with the different plots that I want to arrange vertically, and sure enough, they show up in a nice vertical orientation. So the reason we sort of went through this first is because I really want to show that it's very easy to have all kinds of linked interactions in Bokeh plots without even necessarily having a server, right? There's even more things we can do when we get to the Bokeh server, but even without it, we can do a lot of stuff in standalone documents. So linkages that people are interested in are maybe linked panning, where we have 2 plots that can pan together, or if the ranges change, the other one up responds, or linked brushing. And so we can see how we can do both of these things in Bokeh. So linked panning is super simple. If I want to have 2 plots that share ranges, I simply share the ranges between them, right? So here, when I call figure for S2, I can say something like x range equals the range from my first plot, and the y range equals the y range from my first plot. Here I call figure, and I say x range equals just the x range from the first plot, and it has its own independent y range. And we can see that if we execute this code, we get 3 plots. And what happens if I pan? Well, we can see that the first 2 plots are linked in both dimensions, and the last plot is only linked in the x dimension, right? Because I've only shared that x range. So linked panning in Bokeh is very easy to accomplish. We just share ranges between plots. And that's as simple as it is. Again, it doesn't require the server or anything. If you email this to someone, this is just static HTML with some JavaScript. All of those interactions are preserved as well. Linked brushing is another really nice feature that's very easy to spell and express in Bokeh. If I have two plots that share a data source, then I automatically get linked brushing behavior. And so linked brushing means that when I make a selection on one, the highlighting shows up on the other. So let me actually pick my lasso tool there. And sure enough, right, so if I make a lasso tool and I select the points on this first plot, I can see that the corresponding points on the second plot have also been highlighted. So that's called linked brushing. And again, that's very easy to express in Bokeh without any kind of server or anything like that. I just have to share a data source. So in this case, this is maybe something a little new, I've actually explicitly created something called a column data source. It's basically like a pandas, it's sort of like a very cheap pandas data frame. You can think of it like that. It's just a bunch of named columns. It's basically a dictionary with strings as keys and arrays as values. And so I've given it exactly that. I've given it this data dictionary where it's got X, Y0, and Y1 columns, and they just have lists of data. And then I pass that as the source for my circles. So both of these get the same data source. And then instead of actually passing the literal values here for X and Y, I say I want X to be the X column and Y to be the Y0 column. And I want X to be the X column here and Y to be the Y1 column. So I give it the name of the column that I want to take the values from. And so that's why I get 2 different points. So the X values are the same for both plots, but the Y values here are absolute value of X and then X squared over here. And so that's how we get those 2 plots. But again, we share the data source, so the selections are also shared. And so it's very easy to get that kind of linked behavior in Bokeh. Another really nice interaction that people like a lot is the hover tool. So there's a hover tool built into Bokeh. And if we hover over the dots, we can see exactly that, right? So the hover tool lets us basically drill down into our data, right? So I'll talk about how this works in a second. But let's take a look at an example. So there's that version. This is the standard sort of default built-in hover tool. It's also possible to customize the hover tool with a custom template if you want something to look very different. And so let's take a look at the code above to see how this works. Again, I'm creating my data in a column data source. It's just a dictionary where the keys are going to be these strings, X, Y, and sort of description. And then their associated values are just these lists or arrays of values. And then I can create a hover tooltip. And the user guide had a lot of information about this, but basically you tell it I want to show a label on the hover tooltip, in this case index X, Y, and description. And that's exactly what we have here, index X, Y, and description. So that's what these match up. and then you tell it what you want to show. And so for each point that you hover over, I can get the index of that point, just, this is the 10th point or the 30th point or whatever. I can get the x and y positions, and I can get the value of this description column for that point. And so this is index, so this is the second point. Its x and y position where the cursor is there, and its description is C. And so we can see, sure enough, 0, 1, 2, the second point, has this description C. And so each of these points lets me drill down and see sort of maybe further information about it. There's also this custom hover. We won't go into details about that. Basically, it's a little template, kind of like a Jinja template, that lets you specify sort of a custom HTML appearance for this, and works out really nicely. So there's a lot of information about that in the user's guide as well. If we go to the user's guide, and we go to, I think that's in tools. All right, so if we go to configuring plot tools, we can go down to, there's a lot of information about different tools. We can go down to the hover tool, and there's a lot of information about the custom tooltip. This is what those templates kind of look like. We can give sort of custom HTML and say that we want, we want to show the description field in here and the index in this, and we get a nice customized plot. So we have a lot of configurability. We can see exactly what we want to see for the tooltip. Okay. Another thing to mention is that Bokeh plays quite well with Jupyter Interactor. So Jupyter has its own widget set. The Jupyter Notebook has its own widget set, and so you can use Bokeh together with Jupyter Interactors really well. This has also recently been updated and has some nice new features. The key is this push notebook function. So what happens basically is if I have a bunch of, a plot or whatever that I create in Bokeh, if I change values on that and I call push notebook, then the plot inside the notebook will update, right? So anything that I change will update. So that can be useful for this callback function for the interactor. So let's go ahead and sort of see a concrete example. I create a bunch of stuff there. I create a plot. It's just a sine wave. And then I call IPyWidgets. So if you aren't familiar with it, I'll just point you at what this is called, and you can look up more about it. But this is the interact function. Basically, you give it a callback, and then you give it a bunch of fields, and it automatically creates widgets for you. So here I'm going to give it a list of functions, a list of numeric ranges, and so it's going to create sliders and drop downs automatically for me without me having to, I need to install, of course, conda install IPyWidgets. Unfortunately, I may have to restart. I forgot that it's not installed by default. I didn't install it in this directory. So let's try restarting here, but I may actually have to restart my notebook server. Actually start at the top. Scrolling, there we go. Got our plot. Yeah, unfortunately, I don't know why it does that, but I've noticed if you don't have IPyWidgets installed when you start the notebook server, it doesn't actually work. So let's just restart right quick. There we go. So we'll, again, execute down to the bottom. And there we go. So now we get this nice set of widgets here. And again, this is all part of Jupyter. It's giving me a drop down for the the list of explicit string values I gave it. For the numerical ranges, it gives me sliders. And the important thing to note is that if I change this slider here, then the actual plot inside the notebook updates as well. So I can use sine or cosine or whatever. And the way this works is, again, whenever any one of these widget values changes, it calls this update function, which says, well, if the dropdown is sine, I want to compute the sine, and then I want to update the data in my data source, and then I call push notebook. And so that's the magic that sort of ties this together, and this is what makes it really useful to use in the Jupyter Notebook. All right. Bokeh has its own widgets, though. These are really useful. They can be useful in the notebook, but they can also be useful in Bokeh applications, which we'll talk about next. So how does that work? So for instance, I want to have maybe a slider. And so here I import slider from Bokeh model widgets, and I can just give a slider a start, end value, a step size, and I can just show it. And sure enough, I have a slider. So what is that good for? We'll see in a minute how that can actually be useful. But I'll go ahead and let everyone do an actual exercise. If you go to the user's guide or the reference guide, you can see how to use a select box. Let's just make a select box right quick. I'll leave that to see if I remember. So whatever one, there we go. Great. So take a look at that. Again, if you go to the user's guide, there is a section, I believe, on adding interactions. Yeah, there's adding widgets under the adding interactions sections, and so you can see actually a lot of examples here with some sample code as well. And so I can direct you to there to look for information, or you can just look at what I've done here. But this is maybe a quick exercise that we can do, is to try to create a select box instead of a slider. Maybe while y'all are working, I can also say a few words about sort of good ways to use the Bokeh documentation. We have a fairly extensive user's guide at this point. There's certainly still parts that we want to add more to. We also have a really nice reference guide that's automatically generated as part of our build and sort of automated test process, and so it's really always up to date every time there's a release. As I mentioned, all the things that make up a plot or a visualization are called models, and so basically if you want to look up what properties any particular model has, you can go under bokeh.models. And you can see there's a bunch here. You know, there's layouts and grids and glyphs. And in this case, we're looking at widgets, and we want to do it's an input widget. So we can look down here for select. I think it's on this page. Multi-select. There we go. Class select. And so it'll tell you exactly what it's got, right? So it's got this options attribute, which is the list of options that you want it to be in the select box, as well as this value property as well, which is whatever the initial value is. Probably less interesting, but if you're really curious, you can dig down into this JSON prototype for what it looks like. If you are ever interested in writing another language binding for Bokeh, this is, for instance, what would be very useful. So folks that have written rbokeh or bokeh.scala or bokeh.lua, they would use this information to know how to generate the right JSON from those languages. But anyway, yeah, the reference guide is really helpful. Obviously, it's helpful if you sort of know what you're looking for already, if you know where to sort of start. So the user's guide and the reference guide both complement each other in that way. OK, so we get on here. We've got our select box here. I just, again, I imported select. I called select. I gave it a value of foo, so that's the initial value, and I gave it these list of options. And sure enough, if I look on my select box, I can see those are the options there. So I mean, that's great, but unless I can do something in response to the widget changing, it's not too terribly useful. So what can we do? This is one area where we relented or compromised a little bit, sort of, I'll say in a minute, is that we added something called a custom.js callback. And basically, the custom.js callback is a concession to the notion that, well, if you write a little bit of JavaScript, you can actually do really, really powerful things in standalone documents. And so this is a way to sort of inject a little bit of JavaScript into your Bokeh documents. Here's an example. I create this custom.js object. It's got a code property, so I give it a little snippet of JS code. In this case, I just say alert hello world, and I attach that to tap tool. And that means if I tap any of these objects, it's going to bring up an alert. Right? So you can imagine there's actually a lot of things you can do with that. There's a lot of places in Bokeh where you can add callbacks. On widgets, any of the widgets, basically, you click a button, you select something from a dropdown, you type into a text field, you move a slider. Any of those things can have these little JS callbacks added to them. Tools, et cetera. If you make a selection, if you do a tap tool, if you change the range on a plot by panning or zooming, you can do callbacks when those happen as well. So there's a lot of places where you can inject these little bits of JavaScript code. So let's take a look at a little bit more sophisticated example. Here's one for a widget. So this one, I've got a slider, and here's the bottom, with a start and an end value, an initial value. I've got some data here. It's just x to the n, for some value of n. And then my custom.js callback looks at the slider, gets its value, and then it recomputes a new set of y values. And so let's see what it looks like first, and then we'll take a look at the code, right? So I've got my plot, I've got my slider, and sure enough, if I scrub the slider, that's fun. If I scrub the slider, I can see this updated. And again, this is not using any kind of server. This is just a standalone HTML document. This would be preserved, you know, if you emailed it, if you put it on a web page, it's just serve it statically. This interaction is still preserved, right? So there's a lot you can do with sort of these custom JS callbacks. And so again, it's, you know, we get our data, we get the value from the slider, we pull out the X and Y columns of the data, and then I just have a loop here that says math.pow. I just raise X to whatever value the slider has, and then I call source.trigger to tell the plot to update. And so that's my little tiny snippet of JavaScript that allows that to happen. I will mention, though, in some cases, it's actually possible to write that in Python now and have it compiled to JavaScript. We're living in a world where more and more things are compiled to JavaScript, so why not Python too? If we go to the user's guide, we can go to adding interactions. We can go down to the very bottom, and we can see the same example here, but now the callback's actually written in Python. And this is compiled, so just to be clear, the Python's not executed, it's compiled to JavaScript, but it still works exactly the same. And so we can see, you know, I get the data, I get the value from the slider, I get my X and Y fields, I call math.pow, and then I call source.trigger. And so that's sometimes useful as well, is that we can just write it in Python and it still turns into this nice JS callback. And so this was originally... It is part of Bokeh now, yeah. So this was largely written by Almar Klein, who works on VisPy and PyScript, and so and Bokeh. And so this is interesting. This was at first a Python 3 only feature, because that's what he wanted to support. We convinced him that Python 2 was still, at least a marginally useful or important use case. And so now Python 2 is supported as well. But he wrote the PyScript library that does this conversion, and it's used in I think Flex. He also works on, and then maybe part of the VisPy work. So. But yeah, so it works pretty nicely. Okay, great. Callbacks for selections. Here's another example that's kind of cool. Let's see what it does first, and then I'll explain about the code. So here, I got a lasso tool, and if I actually select a bunch of points with my lasso tool, the yellow line moves, and it shows me where is the median for all of those points, or the average rather, so the mean, not the median. So if I make a nice little narrow thing here, that's great. If I make a sort of a weird, shape, it's going to do whatever. It's just going to keep updating, right? So it works also with multi-select, right? If I hit the Shift key, I can do multi-select, and it'll update based on multi-select. I'm not sure why it's doing that weird selection. Anyway, so how does the code that does that? What does that look like? So this was a little bit more involved. Might be nice to redo this one in the Python that compiles to JavaScript. But the basic idea is that I attach a custom JS callback to my column data source. S.callback equals custom JS. And this callback gets triggered whenever a selection is made. So anytime any tool causes a selection to happen on the data source, it will call this callback. And what does it actually do? Well, it gets the indices of all the selected points. It's going to get the data. It's going to loop over all of the indices, and then it's going to compute that y value. Right, so it says, what's the y mean value starts at 0. It's going to loop over all of the indices, and then it's going to add the y value of the selected points to this mean. It's going to divide it by the length of the selected points, which gives you the actual mean value for the y. And then it sets the data source for this yellow line to be that mean value. And then when it calls the triggers, then that's what actually happens. Let's take a look. There we go. So that's what it's doing. So again, it's as the selection changes, it recomputes that mean value, y value, with this little loop here in JavaScript, and then it sets the data for that line to be this y value. Okay. So that's cool. So I think we're definitely running a little behind, so now I definitely want to turn to the server stuff. So things that we're skipping here, running out of time. There's some notes about embedding and sharing plots using the Bokeh.embed API. It's fairly straightforward. You can embed these things in Django or Flask applications, however you want. There's a section here about models, which is sort of the lowest level API. Again, I said everything is really comprised of models. It's sort of the building block layer. If you can imagine, you got all these sort of Lego parts that you can put together, whatever you want. This is the most verbose sort of API, but it's also the most flexible. It gives you complete and total control basically over everything. And there's also, I will mention another new feature, is that it's possible now to extend the model system with your own custom models. So just to quickly run through this notebook, just to show what's in here. My scroll is behaving very strangely. So import the data. So this is reproducing a chart from the New York Times. This chart about Usain Bolt's sort of his Olympic performance. We get this nice hover tool, like executing, that sort of shows, what's the person, how far behind are they, and this is a nice reproduction of the chart. But we're able to reproduce it so well because, again, we're sort of working at this very low level. But you can sort of work through the example. But I did want to mention that it's possible to make custom user models. And again, this is actually, I think, nice because this means that it opens up sort of the floodgates for users to start experimenting with new features or new functionality without having to sort of dive into a full development environment. Like, developing Bokeh is a little bit of a chore to sort of get your environment set up, but now you can do that on any release version of Bokeh. You can start developing your own custom extensions, and I think it's going to hopefully open up a lot of really exciting sort of contributors, sort of extensions that maybe users contribute to the library. Just as an example, we have to create some JavaScript code to create an implementation for that, but we can create a new model, in this case a subclass of HBox, and we want to give it this border color property. And what it does is that it styles the CSS box for this HBox using that border color. And so if we just run it, the main thing is just to run it and see what it does. If I run these, then sure enough, I said border color equals fire brick. If I say border color equals navy, then it changes, right? So I have this customized HBox that has this special behavior. And yes, it did require me to write a little bit of JavaScript. So this is extending this Bokeh with this JavaScript. So this is something advanced users might do. But I'm really hoping that this allows people to not have to wait on us, right? There's any number of features that people might ask for or want that either we can't get to in time or fast enough. But this is sort of a shortcut route for people to develop their own features. So you could imagine wrapping other JavaScript libraries this way. So if you want to have maybe a D3, really sophisticated D3 projected map that's actually powered by Python Analytics, you could wrap some D3 with a custom model that ties it back to the Python. And I think that's actually a really compelling use case that I'm going to try to work up, maybe an example of that pretty soon. OK, but I would be remiss if I don't talk about the server some, so let's do a little bit about that. So first off, to note, these exercises really require working outside the notebook. If you want to follow along, that's great. Otherwise, I'll just go through it pretty quickly. So I mentioned that there's this notion of the way Bokeh is architected that there are models in Python, things for plots and axes and glyphs and data sources, all those things, and they get mirrored into the browser. So the browser has this same picture of things. So how does that, and that's really useful. But what the server can do and take it to the next step is it can keep those two sets of models synchronized. So if something changes on the server, the clients automatically update. If something changes on the browser, the server automatically updates. And that two-way communication is really valuable. So let's take a look at an example here. This is just a hello world in Bokeh. So let me go ahead and create a text file that has that in it. So I'm just going to use VI. I go here, hello.py. There we go. I'll talk about the code here in a second. And then if I say Bokeh serve -- show hello.py, I get this nice page, and it's the styling is not very good. I haven't done anything to style it, but I can say hi, and it says hello Bokeh. Or if I say hello PyData London, and I say hi, then it says hello PyData London, right? So the application here, anyone that navigates that URL will get this application that's responsive. And what does the actual code here look like? Well, so I've got some imports. That's great. I create a button. Button said say hi. I create a text input field that allows me to type in whatever I want. I create this output paragraph that lets me write text to it. My update function just says copy whatever's in the output, whatever's in this input text box, say hello, with that, and put that in the paragraph. And that's my on-click update. I put everything in a layout here. I've got some HBoxes and VBoxes, and then I call this add root, and that's it. And then I call Bokeh serve, and then I've got this responsive web application. So that's kind of interesting. So that just illustrates the core functionality of tying these Python models to the JavaScript models seamlessly and transparently. And so you can have these nice applications that that don't require any sort of, you don't have to write any JavaScript to do that, right? So you have this web page that has widgets and responds and calls Python, and you didn't have to write a lick of JavaScript to make that work. And so I think that's sort of the point. Let's see another example that links plots together with widgets. So here I'm going to call this app.py. It's a little bit more involved. It's actually hard for me to, there we go. So we'll call this app.py. I'll copy and paste this. So vi app.py. Let's run it, and then we'll talk about it. So Bokeh serve-show app.py. And that opens up another app. And so here I've got a bunch of points. But maybe I want to have more points, right? Maybe I want to have 2,000 points. That's fine. Maybe I want to see a different color. Let's go to olive or to goldenrod or whatever. And again, we could go down to 20 points now, or let's do 10,000, right? So all of that works fine. And so again, anyone that sort of navigates to this, I'm running it locally on my machine, but you could imagine deploying this kind of application. And there's lots of ways to do that. We have a lot of extensive documentation on deploying Bokeh applications behind Apache, behind Nginx, if you need to scale them out, if you need to run them behind load balancers. Bokeh server applications are very horizontally scalable. So basically, if you need more capacity, typically you can just run more. So it's really nice in that regard. And so we have a lot of documentation about that in the user's guide in terms of how to deploy a Bokeh server. But it's very easy to run things locally like this, or just to serve them. If you have a small internal group or network, you can certainly just serve them very easily just by running Bokeh serve. But we also have a lot of information for more sophisticated cases as well. OK, so let's take a look at one more example here. Not Bokeh docs, we want to go to server. Last example, streaming data. We also added recently this stream method to column data sources. And so that's maybe a cool one. Let's take a look at that as well. If I vi stream.py, stream.py rather. Let's run it. And we'll talk about the code here in a second. So what does this do? Well, it brings me up a little pot. What did I do? Oh, I mistyped stream is what I did. Oh, right, needs a comment. Thank you. So this draws something, and it's going to let this update, right? So it's just sort of updating the streaming data. It's streaming new values to this set of coordinates to draw these circles at. In a very efficient way. So obviously, given the way that we have this sort of automatic, synchronization, in a certain sense, you could just stream data just by updating the data source. But if you have a use case where you're always sort of appending a new value, a next value, there's a lot more efficient ways to do that. And this stream API lets you do that. Let's take a look at the code. What do I have here for my stream example? So I've got a figure, right? Just like we've been doing all along. I create a circle on that, just a big circle with radius 1. I create a new column data source for those little tiny circles. And in this case, I start with just one of them. And I create it, and I give it that data source. I have an update function here that looks at the last, whatever the last little tiny circle is, its x and y coordinates, and then it rotates it. So you don't need to worry about the trig stuff here, but basically what it does is it rotates it by a certain fixed angle. And then it streams that new value into the data source. And the way this works is that new data should be a dictionary that has the exact same columns as the column data source you're streaming to. You can give it a rollover value that tells it how much data to keep, right? You don't want the data to just grow without bound, right? If I don't give this rollover value, it's just going to keep infinitely appending data. So I want to typically give a fixed rollover value so that it truncates the data at some point. Let's give it a different one. Let's give it, excuse me, give it rollover. I don't know. Anyone have a suggestion? We'll give it rollover equals 18. And let's change this periodic callback. And so we also added a periodic callback here that says how often should this callback be run. And so I lowered it down to 50 milliseconds, and we can see it's a lot faster. And now there's more. I've kept more of the data by increasing that rollover value. And so again, this is a really fairly efficient way to do that. Let me demonstrate some other ones that are built into the examples here right quick, just to show things off. Definitely running out of time. Under examples app, there's quite a few examples here. If I do, this is a fun one, this OHLC chart, right? So this is a chart that's generating synthetic data, return data. You can imagine it's also creating, computing the MACD indicator down here, several indicators. It has some widgets at the top that let me control the simulation. Maybe I want to have a much higher mean, or I want to have a wider variance. I can also control what kind of moving average, a different tick. I can move this around. I can tell it to start resetting to the updating. OK, so I've got this nice web app. How many lines of code would you expect to have to write? Huh? I can't do 10. You have to go higher than that. But including the actual code to generate the data, the simulation itself, and the code to do it, this was less than 100 lines of Python code, right? So that's including the fake data generation, right? And so that, I think, is pretty cool to get this sort of streaming deployed web application without much or any JavaScript in this case. Another one, we have this nice movies clone here. It's kind of a little cross-filter tool. Lets me sort of say, hey, I want to filter by the number of dollars at the box office, or I want to see different genres or things that were only released before 2009, or how many Oscars it has to have won a certain number of Oscars. And I've got this nice hover tool, lets me drill down. So this is, if this is familiar, there was an R-Shiny example that's very similar to this one that we sort of used as inspiration. We also added, though, I think, a nice touch, the Razzie Award winners, so we can see that how much money a film makes is not necessarily correlated with whether or not it wins a Razzie. Anyway, so that's another example. Okay, so that's the server. I had actually hoped to say a bit more about that. I got behind on time, but quick questions about that before I pivot to one last topic, and then maybe a few questions. Any questions now, though? Okay.
Is there a limit to the streaming of data?
So the streaming, as I said, when you use the streaming API, it only sends the new values, which is why it's a lot more efficient. Again, if you specify, if you don't specify a rollover, you'll start accumulating data in the client, which is eventually not going to work, especially if you're updating quickly. We do have other plans to add, for instance, some binary array protocols. So all of the communication with the Bokeh server is now done through WebSockets, a much sort of more robust WebSocket protocol. But it's still doing basically JSON all the things. And so we're going to add some, transparently, some binary array protocols that should actually improve the performance there even more. But it's already quite robust. So, yeah. Okay, well, let me pivot a little bit. I have a couple of slides here for something called a new project that's under the Bokeh organization. It's called Datashader. Let me just say a couple of words and maybe show a quick example. So this is something that we had originally wanted to put sort of in Bokeh, and then we realized that it really could be a separate sort of project. It's sort of a pipeline for data visualization that we could hook up to Bokeh, and maybe that'd be better for both projects if things were separate. And so there's now a new project called Bokeh Datashader. It's headed up by Jim Bednar, who used to work at the University of Edinburgh. He's in Austin now, works at Continuum, and he's sort of heading up this effort. So, Bokeh is really nice because we can sort of pass this data to it in a very easy way from high level. And it works pretty well, into the tens of thousands, maybe even the hundreds of thousands of points. We have some nice features for level of detail downsampling, for instance, if you're panning. It'll only show a fraction of the points so that the panning stays responsive. But, eventually, if you don't want to send 1 billion points in the browser, right? Even if you could, you wouldn't want to do that. Partly because just you run into visualization problems, not even technology problems. If you try to do a scatter plot of 1 billion points, you get overplotting and you can't see the data that you want to see, and so it's not very useful. And so Datashader is about building visualization pipelines that can sort of mitigate these problems of overplotting, underplotting, all of these sorts of things. And so there's this big pipeline architecture. I'm not going to go into details. Basically, it does what you imagine sort of a synthetic rendering of the data. And then the nice thing about this step is that it can be very easily parallelized. And so we've actually done that with the Dask library as well, the open source Dask library. And then the resulting aggregate can be sent to the browser. And you can still do a lot of interesting transformations on the aggregates. But the key is that those transformations are very fast. So here's an example of the New York City taxi data set. This was done with 10 million data points in this. So this sort of reveals the entire data set. If I actually go down into a notebook and have it running, here we go. Got New York City taxi running in here. So this is the New York City taxi data set, and you can see this notebook in the repo. But we've basically added some visual query steps to it. So Datashader also has these nice sort of visual query things. I want to shade areas where pickups are greater than drop-offs, sort of blue, and where the converse is true, I want to shade them red. And so we can sort of see the structure here. And obviously in Manhattan, it's not too surprising. Major streets and thoroughfares are where the pickups happen, the drop-offs happen on these cross streets. And because we know about Manhattan, we know that these big vertical avenues are the major streets. But what's kind of interesting is that you can see that's, in Brooklyn, we don't know we don't have that same grid structure, but we can infer that now because we have this information. We can actually shade the data, and we can infer what are the major streets here in Brooklyn. This, by the way, is now updating the full 10 million point data set, right? So this is actually running on my laptop. So as I zoom in, you can get to levels of progressive refinement. You can get to the level where you start to see individual measurements, right? Progressively refined. There's some really cool things you can see. I always like to zoom over here in the Javits Center. So there's a big giant convention center here on the west side of Manhattan called the Javits Center. Has this big circular parking lot in front. And you can see the taxis come in and they drop people off and they immediately pick people up and they go out, which I think is kind of cool. But you can see all these sort of pattern of life kind of things sort of start to emerge from the data sets when you can ask these kind of questions. And this kind of visual shading, this kind of shading here, this is the fast part. you can sort of ask these questions and tell it to update those things very quickly. Another one, just to show off another example, this is, I think, how many data points is this? This is only 1 million data points, but it's a trajectory, XY points, looks fairly straightforward. But if we zoom in, we see that it's actually got a wiggle at a finer scale all the way through. And if we zoom in further yet, we actually see that there's been noise added at the smallest scale. And so the question is, can we actually be able to sort of look at this in a dynamic way? And again, with Datashader, I can zoom into this here, and I can start to see progressive refinement, and I can get into the detail at any area of the plot sort of as fast as I want. And so this, again, is the Datashader project. It's pretty new. Definitely, is at the stage where, people coming in and taking a look at it and banging on it, giving really good feedback is what will help move the project along even further. So I encourage anyone to has sort of requirements there to look at Datashader. A few more slides here, and then I'll let you go. Lost my too many windows open. There we go. Just an example for processing really large scale data. This is the OpenStreetMaps data set. It's about 3 billion GPS coordinates. If you have the RAM, that's great. Datashader processed this in 7 seconds on an EC2 with 128 gigs of RAM. But the thing is, you can actually do out-of-core computations as well. Because this is powered by Dask, which can do out-of-core scheduling, you could do this on your Mac. In fact, Jim did that, and I forget how long it took. Obviously, since the data set won't actually fit in memory, it takes quite a bit longer, but on the order of maybe minutes to process 3 billion points on your Mac, as opposed to much longer. So anyway, that's a shading of that. The census data is another nice example. I don't have it running here with me, but it's cool because this is fairly novel, is that you can have all these data. So this is 300 million points, the US Census, but it's tagged by self-selected racial category. And so you can actually have Datashader combine these in more sophisticated ways, right? If you just plotted all the points, plots would stack up on top of one another. You would have overplotting problems. You wouldn't be able to see. But because of the way the Datashader pipeline operates, it can actually modify and merge these in much more sort of efficient and visually efficacious ways. And then if you zoom in, again, you get to the level where you start to see individual dots for the individual measurements of the census, and it's pretty nice. Anyway, these are things it supports currently: time series, heat maps, trajectories, that sort of thing. A lot of examples here. I think they're looking at some of the Uber data set is maybe one of these, and this is some of the census data set. There's quite a few interesting things and a lot of examples in the repo. So check it out. Conda install Datashader. It's on GitHub as well under the Bokeh organization, and there's several notebooks up on anaconda.org as well. So apologies that I didn't get to do quite as much hands-on stuff for the servers. I'll be here, should be here most of the weekend. Please come by and ask me questions. I'd be happy to talk about Bokeh or any other open source projects. Any last-minute questions before we adjourn? Yes? Yeah, so the question is, what are some alternatives to Bokeh? And there's an endless number, basically, of plotting tools. Obviously, in the Python space, Matplotlib is a fantastic library. It's been around a long time. One area where Matplotlib currently has a definite advantage is if you need static output, like programmatically generated SVGs, PNGs, hands down, Matplotlib is going to be what you want for now. We are working on adding SVG output to Bokeh and also making that programmatically available. Beyond that, I would say it's sort of a toss-up. If you want to deploy something to the web, definitely Bokeh, I think, is maybe a good place to start, especially if you want to be able to have these sort of server applications, right? I mean, all that infrastructure is just built in and sort of takes away the burden of having to write the client-server architecture and having to write a lot of JavaScript, and so it's really nice. Other libraries, obviously, I should mention we also have some level of Matplotlib compatibility. It's not complete. We use a third-party library that only handles some things, but it gets a fair amount done. If you're coming from R, obviously you might be inclined to look at like ggplot, and people love that. I will say there is an R binding for Bokeh that Bryan has created, so you can go to R Bokeh and you can see all of these plots. These are generated by R. These are Bokeh plots, but generated from R code. And so I'm actually not, I haven't used R in a good 20 years, dating myself, but the ggplot is really fantastic. I think Bokeh is pretty cool too, and so again, I think maybe it's sort of a toss-up there. I know people are working to make our Bokeh integrate, for instance, with Shiny really well and HTML widgets. And beyond that, there's things like D3. D3 is also a really wonderful library, but it's also a JavaScript library, so you really have to want to start from JavaScript. It's sort of, I consider it maybe an artisanal tool. You can make these amazing sort of, as Sarah would say, webby, responsive, just beautiful graphics, but you got to put fair amount of effort into it, right? And you've got to work from JavaScript and deal with a lot of CSS and HTML and SVG and all this JavaScript manipulation. And so we're trying to sort of back away from that a little bit, and maybe we sacrifice a little bit of the webby sort of responsiveness, but we're trying to get to that 90% use case where people can do more with less code, right? That's the sweet spot we're trying to hit. If I said something in general. Beyond that, there's other certainly commercial products. There's things like Plotly and Tableau and HighCharts, and they are all have their own uses and advantages as well. So there, it's just a matter of does it fit your particular need. So I don't know if that answered your question, but hopefully some of that was useful. But yeah, one more question.
Dashboarding. Is there a capability within Bokeh to create dashboards, or are you reliant on what's happening back in the Jupyter Notebook project?
So we want to converge and integrate that with that really well. I mean, part of as I mentioned, we're working on a lot of sort of automated layout improvements right now, and so part of that I think will fall out into Bokeh apps, the ones that I demonstrated here. Writing a little bit of Python code. In terms of like a higher level, you mean like a tool for creating dashboards, like a visual dashboard creation? Maybe, yeah. That's a little bit further down the road, but we're certainly interested in that. In the effort that's going into Jupyter Workbench, into Jupyter Dashboards, there's a lot of, I think, interesting places where we can connect and converge there. Absolutely, writing dashboards is something that we're, being able to create nice dashboards is something as easily as possible is something we're interested in furthering. So yeah, stay tuned, I guess, is my answer. Okay, well, I think it's right at noon, so I think that's the stopping point. But thank everyone for coming. I hope it was useful. And like I said, thank you. Feel free to come and find me anytime over the weekend.